Hello, diamonds in the rough. So this will be the first video of our AI series, and in this part what we're gonna do is I'm gonna explain you AI without using any maths. So you don't require any hard math or something. If you just know addition and multiplication, you're okay to go. And the goal is to teach you the overview how AI really works, like how machine learning works, how a model is trained, how a model looks like, and we're gonna learn this through a self-driving car example, right? How car basically steer itself, right? If you see Tesla or any self-driving car, how they work is there is cameras over there, and then your steering is controlled by some mechanical device, and the camera takes the image, process it, and gives you the direction where you want to turn your steering or something, and that is passed to a mechanical device which turns your steering, right? That's how it like takes left turn, right turn, or if it has to stop or something, whatever, right? So that's how self-driving car work, and that is a very good and simple example through which you can actually understand how AI works, and you will learn about what is input, what is training, what is model, and these all things. So let's get started. How self-driving car works. So as I told you, we have an image, and the way computer AI decide is basically how much rotation I have to give. Like if you see this road is a right turning road, so though I have to rotate my steering in a clockwise direction. This is how a human would drive a car, right? And once you like you can see that is quite a steep turn over there, so you have to rotate at least plus 5 degrees or plus 5 units of rotation, like you can see. Same way, if there is another example, left turning road, then you have to actually rotate in anti-clockwise direction, and instead of telling anti-clockwise, you can write minus 4.7 or 5 or whatever the turning angles are, right? So that's how a human drive. And we can also, the AI works in a such a way that it try to mimic the data. So what we can do, we can create data set out of this thing. Right? Data set is basically one example, image, and its rotation. So we have two things over there. One is input data and the output data. Input is a right turning image, and what is steering angle, plus 5. We have a left turning image, what is steering angle, minus 5. So there will be two kind of data, input and output. And our goal of the machine learning model is to get the input and get the take the input and get out the output. And the way you get the output is basically you have to match what was there. So what happens is, for AI training, initially we train with known steering angles. So we will have a left turning image or right turning image and their angle. They are known, right? And the model will try to fit that data inside its permutation, combination, whatever you can say. And once the model is trained, you don't need to give out the rotations, right? It will just take the input and it will rotate automatically. So input is image and gives out rotation 5. Like this is a car software as we have described. Same way, this is not turning anyway, so it's 0 it is. So that was the training part at dataset. Dataset is basically, if you remember as a kid how we used to learn anything. Kid were so oh, this is a dog, and we tell them, hey, it is called dog. If it is a wood or something, it will tell it is not a dog. So that is how human learns. And same way we want to teach machine that if that image is dog or cat or whatever, right? That way they identify that object. And future, if you even it doesn't has to look like same dog, but if you had any slight features of the dog, the child gonna see and it's gonna say dog, right? If you see a little child for the first time, if you show him dog for a long period of time, suddenly you show him a fox, he will still say it is a dog, because for the first time he is seeing the fox. That's how human learn, right? We have input and we have a label, right? That how we teach to kid, and same way we kid AI and machine learning world the same way. Dog, yes, this is a dog. So training and data set, basically we collect data like this. We will have two columns or whatever you can say. In one column we'll have image and the output is -5. And if you have this, if you see right turning road, it's 10. And this is straight road, so that's why there's no turning is required. Over here -5 is because it's turning toward right side, right? So one will be clockwise, one will be anti-clockwise, something like this. So if you see, we have seen our data, right? The data looks like image and a label. And the problem with our data is that when you are trying to take left and right hand, you don't really care about colors in your image, right? In the data, you have seen mountains which have brown color, trees are of green color, and the roads are white or black, whatever, right? So we don't really need the color information. If you see your driver is color blind, right? He will still drive the same thing, and he doesn't have to think a lot. So what it helps for machine learning, if we suppress our data to simple things, it's more easier to process and to like do, because if you think self-driving car has to be very fast, so the model or software should be really fast. Otherwise, if you are any late, you will go that like you move ahead in the direction and you take your rotation very late, and that would not be really helpful. So just to make simple, and usually people does it, they don't need colors information. So what we can convert the colored image into a black and white low resolution picture like this. And so that is called pre-processing part, basically converting our data into a way where it could be digestible to the model, right? So what this pixel values means over there is basically the white pixels are basically glowing pixels, so they will have some number. So if you know how images digitalize in a computer, basically if you have to see a black and white image, basically the glowing parts have like basically they are LEDs. The pixels are, you can think as LED, and to glow them they need some kind of electricity or something like this. So to glow them, you have to say, okay, this is the glowing, how much intensity it has to glow. So these glowing values are basically big numbers, as you can see, 56, 43, and the black parts are 0, 0, 2, something like this. So they don't have to even glow. The LED can shut off and just work as the same way. So we can convert image into this digital form, a simple digital form, where the glowing pixels have some value and the darkened ones doesn't have, or have very little if they are gray or something like this. We can convert image so that becomes a number. Everything, whenever we do any kind of modeling something, all the maths is applied to numbers, right? So somehow image is even though already in digital, mostly it is digital. If you think about sound, right, they are analog signal or something, so even we have to convert into a digital form, and then digital becomes 0 and 1. So any AI model working on sounds as well, they are also converted into digits, same way this image is converted into simple digits. So this image, so this was the first second step, convert into grayscale. Then we have this numbers, right? And then the third step is to break down number into an array form like this. If you are familiar with programming, these are arrays, right? So the same first image, you can see if you see this first image, convert into array like this, convert into black and white, and then flatten it like this, and that becomes the input numbers, and the output label is -5. Same with the second image, that also goes like this, and third one, because it's not turning 0 something. So all the 5 or 6 example, it could be, for this part we are doing examples very little, so all the examples has been converted into like this, arrays like this, and the label, right? I think this makes sense. And this example, we have little example because I want to show you the calculation and all, but in real world there will be more examples. The more examples you have, better you will learn, and even will understand why more examples is required, right? So the model is basically nothing. If you have afraid of hearing about model something, it's basically simple. We call it weights. Just like image array we have, with the same length, you have to create a weight matrix, weight array, you can say, right? And that array is basically, you have to assign, initially you have to assign random numbers, right? And this is basically like a child is born. If you remember how child is born, they start crying with random words. Like what is cry? Cry is basically randomly speaking, any voice is coming, right? So that is basically this weights are. Or if you see in the TV, if you remember those old school black and white TVs, right? When you start on the TV, it start with gibberish noise, right? And that noise means it has not been tuned. The channels has not been tuned, and it is randomly showing some black and white pixel on the screen and making some weird sound, right? So that is basically they don't have any knowledge. Same way with this weights, we randomly picked it, doesn't have anything. Child is born, there's no knowledge to him. Then he starts with learning, speaking, whatever, right? Same way we'll also try to see, this is an empty model, the empty child, and we will introduce images to it and they will learn it. So now it doesn't make sense. It doesn't have any information. These are just gibberish number over here. So that is our model which has been born over here. And what is the training part is basically you have to do is take these weights and do matrix multiplication, or like what we call vector multiplication or something like this, right? This is the weight as I have described you. So what we do is we take an example, right? Which is not, so we have 6 example which was our part of training set, and then we take another example which is not part of the training set. It's a random example, and we see this is a left turning road, and what again we will break it into this array form, turning into black and white, then again converting into numbers. And what I want you to do, take the following numbers, like these numbers, and whatever it is in the front, multiply them over here and then add them, right? Which will look something like this over here. Yeah, if you see, if I multiply, it looks like each element, this 0 is multiplied by 1, minus 3 is multiplied with 0, then following that 1 is multiplied with 10, minus 7 multiplied with 11, as you can see. And if I sum them, that basically outputs my model, right? If you remember, this was a left turning road or something like this. So our model prediction, what the summation we did over there, multiplication summation, gave me a value 68. And the actual label, the turning which we required was minus 9. As you know, this model is not trained, it is empty, it is just has born, it has not seen any data now. So on the random weights, the model has predicted very bad. As you know, it is not trained, it hasn't seen anything, right? Its prediction 68, which is way far away from the actual label minus 9, right? So in the following next part, what we have to do, we have to change these weights such a way whenever I have an image and if I multiply and add them together, I should get value very close to this thing, because then it will rotate the steering of the car in the same way what the actual output has to be given, and then that will make the car on the road, right? So that we have to do actually. And then there is certain problem that I will discuss next in doing that. So it is not like, and how we'll know that how bad this thing is? So we call it model prediction actualable. So if I just subtract these values, right? If I know the difference, it will tell you how bad my model was. We know this prediction is not correct, but how incorrect it is, how we'll know that, right? That will be known by this word called loss. Basically, loss is predicted output minus actual label, and the predicted output was 68 minus 9. And this is the modulus. Modulus, if you haven't learned about mathematical, any subtraction, whatever you do inside these bars, if their output is negative, still will take on the positive part, right? So there is no negative part, right? Why we did it, we'll probably learn in future lectures as well. But over here we can see the loss, how far it is from the actual truth is basically actual prediction is 77 point it is away from actual prediction. So this is pretty bad. The loss is very bad. We call it loss. And our goal is to change this weight. So whenever we in future encounter any new image, right, whose labels we don't know, it should actually predict the actual label, right? So that is the goal. So we'll start the training, and if you know that we have previously collected a lot of data, right? That data we want to train on these weights, right? We want to change the weights according to those 5 data which we have collected initially. And what happens is that when we actually use those examples, right? If you see those 5 examples, if you don't remember, these were the 5. We do the same thing. We take these are the randomly assigned weight, not trained till now. And if I do this on this this left turning image, I think, yes, and the label is minus 5, the predictions came 39. If I again do multiplication and sum, I'll get 45 and 50. So you can see this is terribly doing with all the examples, right? They are very far away. So what we can do, we can find loss, right? Actual minus predicted and their modulus. and I'll get some values, and we can see the very big number, means that I'm very far away from the model, is not trained and it is giving me very garbage output, right? This big number. So what we can do, we can sum all these loss and call it a overall loss, something called overall loss, right? If I sum them, that is overall loss is 342. So now this becomes an optimization problem now. So our goal is to, just like if you remember this example I did from our math series, which is called counting numbers to calculus. Over there we learned about derivatives application, right? You don't have to go there even if you haven't watched. So basically over here the goal is to make a optimization problem, and goal is to change this weight such that this overall loss becomes 0. If I change some number over here, there will be some ripple effect over here, like the prediction will have some different values, right? And then their loss will become different. So each with trial and error, what we can do, we can change these values, and somehow this loss will become little by little, right? And after some iteration, we'll change this number such a way, we'll find this Goldilocks number or Goldilocks points, right, where we will find that the prediction is very much equal to the level and the losses are very little. At that point we can stop and we can say this model is trained. And that time what happens is, whenever you bring new example and then you multiply with your changed golden numbers which you have got after training. Basically training means this changing of the weights and trying to minimize this loss, right, this big number. And then you'll find that whenever the now new example, you will get a really good output, and that will basically act like human and give you right rotation angles, right? So that will call the model is trained. So for that, actually I have created a website for myself where actually you can go and change these numbers and see how it affects over there, right? So that I'll probably show next, but I will add those link of that website in the description so that you can also go and try to change the weights and see how, if you can minimize this loss, right? Overall loss. So you can see this is the website which I was talking about. So over here, these are my input examples, and the actual label and the prediction and the loss as given over here. Green ones are the actual predictions, actual labels, and the predictions are the blue one. The losses are the red one. You can see the losses are quite big, and over sum is 13. And these are the weights, right? And if I change the weight, you can see how it is affecting. Right? If I remove this 3 and make it 1, it became 288, right? Which is in a good direction. Then we can go and randomly change this one, 4 becomes 200, now a little more, right? And if I go and change this -2 over here, this 6 over here, then this 3 it becomes 42. Now you can see the loss is very little, and then the 5 loss becomes 48. So somehow randomly we have to change the weight, and you'll see at some point we'll find a good number where actually the over loss become very close to 0. That is the goal. Even somehow if it is -5, 7, or like very nearby 0, it's all right. So there you will find those Goldilocks numbers by some trial and error. So this is called training, right? And you can see over here right now like how that their difference is basically very little. Actual is -5, or like the actual, if you see the actual prediction is -5, and this is the weights which I've done. You can actually tweak more and actually find over a loss till 0, but it's okay till 10 as well, or 11 as well in this case. So if you see, initially it was 68 or something big number was there, right? And now if you see the actual prediction is -5, actual value is -5, prediction -1, which is very close to the rotation. This means that the road is left turning road, and you require to turn -5 degree of rotation with your steering, and you do -1, still it will be on the road. It will be not that perfect. But if you see this example over here, 10, right? The 10 is basically, if you see 10 over here is actual prediction, actual label, and the 6 is very much close, and the loss becomes 4. And if you see third example where don't have to, because it's a straight road, that labels are coming minus, which is very pretty much close to 0, right? And so yeah, if you change these numbers more in a more better way, this will change. The problem with this changing numbers is like maybe you have a weight which might give you. So let's say for this example, right, this one perfect 7, right? The actual label is 7. you fit in this number, but what will happen that it will break the prediction. The prediction will not match for this other example. Now if we change the weights for other example, this 7 might get ruined, right? It's like very like tug of war kind of thing, right? If you fix it for this, other may wreck. Like if you try to balance for these ones, these will lose balance. If you try to balance this, so you have, it is very like dancing on very icy surface, and it can anytime break off and you fail, and you have to just balance yourself in a perfect place where it kind of balances all of them, tune it in a better way, and it kind of works. So this is just to explain you how we did it. Is basically randomly changing the weights, and this is so this is just for explanation. I told you this, but we have an algorithm called gradient descent, which we actually use it, which you don't have to learn and which you don't have to afraid of now, right? I'm just telling you, where we have to automatically change this weight. There is a mathematical function which helps you, which will tell you which exact values has to be changed. By the seeing this data, we can actually tell you, hey, go and change this one, go and change this one or something. Exactly tell you which ones to exactly change. And you don't have to do more time. 1 or 2, 3 times you'll do, and that's it. So we don't have to go through this hard work of changing slowly, right? That is more like a manual thing. I have explained it because this is how if I have to explain you, like this makes more sense, right? You will understand, okay, we have to change the weight so that it fits all the 6 examples. But we have algorithm which does this for us. And in future lectures, that will be the goal to understand. That is the math part which I'm telling you. If you're afraid of that, we're going to learn it in the next few videos. So I hope you have subscribed so that we can see you and discuss more on that. So that we actually to do. If you see, this one is perfect, like it's wanted to 6 rotation in the right direction, and the model also given the 6 value, right? The loss is 0 over here. So this is pretty good, right? And I encourage you to go to the website. I'll share the link in the description and change those weights and try to find if you can find them. So these are our golden weights which we got through training, right? And that is called, this is model, right? And initially we have this random weights, and we had this image, right? If you remember the first image which we tried, and we multiplied, and we got very bad results, 68 actually. Now if you remember, we have trained our weights with new weights. What I will do, I'll replace these initial weights with the trained weights, right? These golden numbers. And when we see the production, what is the loss or how the prediction came. So with the new weights, you can when multiply and add, I get -10. So this example was not part. If this example was part of the training set, I would already adjusted my number over there. But this example is not part of the training. It's a new example which was not fit in the training, right? We haven't changed the weights according to this example. But it's a new example. See, because in the previous example, right, we have learned and we have this information, all the information about left and right hand has been encompassed inside this number formation, right? This number has some kind of pattern inside it which stores this information magically, right? And this was not part of the training example. Still, it is giving you a really good prediction, right? So the loss for this one will be only 1, right? Which is pretty amazing, right? Initially, we got around 77 in the previous trained weights, but for this example, it's quite good, right? Oh, -10, -9 become 1. So this loss is 1. So you can see this is how the model is trained. And I hope you have understood what is training means, what are weights basically. Weights, the pattern of numbers has all the information inside it. Initially random weight didn't have any information. New combination of these weights has some information about when to turn left or right something. Even if you apply new images, it will make more sense. And if you add more examples in our training example, previously we trained on only 6 examples, and if you more examples in that thing, it becomes harder to find these beautiful numbers. The harder it becomes, harder information. Like, so this number only have information about 6 example when to turn right. With 6 example, it was able to perform really good. But if you think about 600 more example, like a child has seen 600 dogs, right? He never will give wrong prediction for fox or anything, right? Because he have seen more examples. Same if you have more example, all the examples information will encompass inside these number patterns. So the more the training, the better the solution will get, right? And we started with random weights, right? What one thing we can do is there is something called transfer learning. instead of initially starting with random weights, what we can do is we can like, we don't have to, let's say today if I have to make a self-driving car, I don't want to start with random weights and have collect some example. What I can do is we can take from these weights from Tesla. They have trained on so many examples, so many videos they have, so many images they have, and if I just take their trained example and then actually change it for my one, right, that will be like the most best scenario, right? Sorry, this is a gradient descent which I taught you, which takes the inputs and this orange weights and gives you the new train weights, right? And the goal of our few lectures will be to understand this this method, this gradient descent function, how it does it. That I was talking about transfer learning. Instead of starting with random weights, what we'll do is basically we come up with a like, let's say I wanted to train a drone now. I have already done training for self-driving car, and now I want to train for drone. And now for drone, we'll have some sky shots, right? I can start with random numbers, and then model will automatically see these drone examples, and it will learn that. But it makes more sense that instead, if you have a software which is already trained for self-driving, if I use weights of those already trained weights, it has some information about left and going left and right. And instead of random weights, if I take those weights and then start training, my training time becomes shorter. I don't have to adjust too many values, right? It could take the advantage of what we have learned with previous images, right? And there is a slight difference for a drone and a car. They both have to take left and turn, just that the objects are different now. So instead of going from there, we actually are going to build upon something. So that is called transfer learning. Knowledge from one data set or one field can be transferred to another data set with the following weights, right? Nowadays, what we happen, big companies like Google, Meta, or OpenAI or something, they have trained these big models, right? And if I have to today build any kind of this self-driving car or something, I don't have to start from the scratch random weights. I can borrow their weights and change it for my task. Let's say I want to make an AI lawyer, right? So lawyer has to learn English first, right? So I will not start teaching this a robotic lawyer or something about law. Instead, I will need somebody who already understands English. So I will take weights of that model who already understand English, and then I'll try to teach law to it, right? Same way, maybe you can think like this. If there are two guys, one know how to play baseball, another has played any athletic sport or something like this. And if I have to both train them cricket, right, which is very similar to baseball, I think the baseball guy will catch it faster, he'll understand better, and he'll perform better because he already know how to swing a bat and understand the ball. He know how team effort works, how coordination works and everything. So actually, instead of doing from the scratch, you built upon something, right? Take out the knowledge base and just tweak it, and then you make them work. So there the training time become very slower, resources become slower, finding those golden weights become easier, right? So that is called transfer learning that we are doing nowadays. So yeah, that was it. I hope you have understood machine learning, what is model, what is training, what is data set, what is weight, what is transfer learning through this example. And the future goal, the future videos, the goal is to teach you how we can, now we did this by trial and error, changing the weights, how we can automate it, how using derivatives. So if you haven't understood about math, you can go back and check my series which I have made, basically counting number to calculus, where I talk about derivatives and all. That kind of math is used over there. So if you haven't understood math, don't worry. Next videos I will code this whole thing. We'll code this whole thing in Python, which you can see and learn. And there is no maths, right? Just abstract way, just to get your hands little dirty, right? You understand the feel of the what are data and what are model and this kind of thing. So I hope you will be there in the next video. Where we can share the code. And also after this, I'll tell you what is the difference between CPU and GPU, right? How we can make it faster. GPU kind of do parallel processing. So next video will be probably on GPUs and CPUs. How we can do this kind of training on GPU, or what is the difference between CPU or something like this. And then after that, we'll see the code for this one. And once first initial code will be on abstract level, where you don't have to understand the math or something. You will just do and solve it. You will understand how it is done. And the next 4 or 5 coming videos, you will see the math, right? So that was it. I hope you got some values from it. Do leave some comment, opinion, or anything which you want in the comment section. Do subscribe for the future videos. So that is it. So see you in the next one.
Who are you? My guy! I'm gonna become stronger than anyone around!